Good afternoon and welcome to the second lecture this afternoon on mathematics education. If you weren't here for the first one, I'm Cheryl Prager from the University of Western Australia, former ICMI Vice President, and I have the privilege of introducing this talk. Our second speaker in this afternoon session is Professor Marianna Bosch. She is a distinguished mathematics educator and she was the principal organizer of the Congress of European Research in Mathematics Education, CERMI, in 2005. Marianna is a full professor at Barcelona Ramon Llull University. Her research interests range over various fields of didactics of mathematics. She was a student of Yves Chevallard, the creator of the Anthropological Theory of Didactics, for which he received the Hans Freudenthal Medal of the International Commission for Mathematics Instruction in 2009. And Professor Marianna Bosch is the leader of this theory in Spain. I invite Marianna to address us with her lecture on Study and Research Paths, a Model for Inquiry. Thank you.
Thank you very much, Sheryl, for your introduction, and thank you, all of you, for being here. I also want to thank the ICM organizers and the ICMI Executive Committee for giving me the opportunity to be here today and explaining you our research in this mythical conference. As Sheryl said, I work in the field of didactics of mathematics or mathematics education, and more specifically in the anthropological theory of the didactic, a perspective created by Yves Chevallard, a researcher from Marseille in France in the 90s. I was doing my PhD at this period under his supervision, so I had the opportunity to see the growth of the theory and also to bring my little grain of sand, as we say. And as also Shelley said, Yves Chevallard received the ICMI Hans Freudenthal Medal in 2009 in recognition of the foundation and development of a very original, fruitful, and influential research program in mathematics education. I hope I will be able to show you why it deserves such nice words. I will first introduce some basic notions of the ATD to delimit the unit of analysis we work with. This is important to see what kind of assumptions are made in the ATD and also what kind of things are questioned. Then one of these important assumptions will be gathering what we call a pedagogical paradigm, and we will see how we can consider two different paradigms: the paradigm of visiting works, that is losing strength, and that we are moving towards a new paradigm that we call the paradigm of questioning the world. I will then present our research in the past decade around what we call study and research path, a teaching format that is linked to this paradigm of questioning the world. Then we will focus on something that is very important in the anthropological theory, that is the study of the constraints that hinder the development of study and teaching formats. And then I hope I will be able to present a very important open problem that falls from the research in study and research path, and that is linked to the institutional constraints. This problem involves both the community of mathematics educators and the community of mathematicians. So this is a very good place to formulate it. So let us start with some notions of the ATD. A main concern in mathematics education is the notion of knowledge, and also the activity, mathematical knowledge and the activity of doing mathematics. In the ATD, this is approach through the notion of praxeology. This is a new term. It is formed from two words, the praxis and the logos, that are linked together because we think they cannot be separated. These two blocks, the praxis corresponds to the know-how, and the logos corresponds to the knowledge or the theoretical knowledge. They are all made of two terms. The praxis is made of type of tasks and techniques. The logos is made of technologies. That means a discourse describing and explaining the praxis. And then a theory that corresponds to the main assumptions of the whole thing. Rhys Radford, in his talk about this theoretical level of the assumptions of different frameworks. So we have this notion of praxeology, and then a very important postulate, that is that any kind of human activity, and mathematics among them, as well as its productions, can be described in terms of praxeologies. This notion of praxeology was inspired from the work of the French mathematician Georges Bouligan, who talked about the dualism in the mathematical activity. And he describes it in the following terms. He says, on the one hand, we have the problems, which allow to determine an unknown element under precise conditions. And then we also have the synthesis, which keeps tracks of new problems, assemblies known results to coordinate an inventory of methods, operations, etc. He also said, he talked about the dialectic character of problems and synthesis, involving both logics and the process of mathematizing large domains. Let's keep in mind this idea of synthesis, which mathematizes large domains, and that is a complement to the activity of solving problems. With the notion of praxeology, we can propose a definition of didactics of mathematics in relation to the dissemination of knowledge, to the dissemination of praxeologies, and we can define it as the study of the conditions and constraints under which praxeologies start to live, migrate, change, operate, perish, disappear, etc., within human groups. And we can see that these dissemination processes contribute to change, to modify the praxeologies. For instance, they contribute to enrich the logos block because some descriptions of these theoretical discourses are more necessary. They also contribute to assemble different praxeologies to build bigger knowledge organizations, so this mathematization of large domains. And of course, the dissemination also includes a developing of the praxis to adapt to new situations and users. When we study this evolution of the praxeologies, we talk about didactic transposition processes. That is an important aspect of the anthropological theory that I'm not really approaching in this lecture. The dissemination of praxeologies mainly took place through what we call didactic systems. A didactic system is created each time a person that we call Y, a teacher, or a group of persons do something for another group of persons that we call the students X. So a didactic system appears anytime a group of persons do something for another group of persons, know or acquire the capacity to work with a given piece of knowledge or praxeology. For instance, when now I'm trying to present you the anthropological theory of the didactic, we are a didactic system. I'm in the role of the teacher, you are in the role of the students. And there's something here that I'm trying to define more or less, which is this piece of the anthropological theory. But we can form didactic systems in different ways. The most classical is the first, with a big class, single teacher, and then a curriculum form of a list of a body of praxeologies. There can also be an auto-didactic system when somebody wants to learn by him or herself a given body of knowledge. And also some very labile systems when just somebody that can spend some minutes to show another one how to do something. So there are a large variety of didactic systems. When we analyze these systems, we can distinguish 3 dimensions or 3 types of analysis. The first one, we can call it the restrictive didactic analysis. I put the quotation marks because to me the didactic is everything. But the first one is the more classical, understood as didactic. So it corresponds to how to make a didactic system evolve. What can do the teacher, what can do the student. This is about the dynamics of the teaching and learning process. The second dimension, which is very important, is what we call the praxeological or the epistemological analysis, and it starts with the question, what is this piece of knowledge, this praxeology, that is to be taught, or that is teaching, is being taught, or is being learned? And finally, an important aspect is the ecological analysis, which is concerned with the conditions and constraints affecting the existence and the evolution of didactic system. Usually, innovation is mainly concerned with the didactic analysis in the first way, how to make didactic systems evolve. We are today focusing on this ecological analysis, which is something that is very proper of the ATD approach. What are the conditions and the constraints? To analyze this ecology, these conditions and the constraints, and also to see what is assumed when we do the analysis and what is put under question, there is a notion that is called the scale of didactic codeterminacy. The first thing is that didactic systems, they do not exist in the vacuum. They are somewhere. They are in schools. And not only in schools, but they are in pedagogical cultures. And these schools are in societies, which in turn belongs to civilization in a big thing that is humanity. And we can consider different types of conditions at each of these levels. For instance, in the pedagogical level, we are considering all the conditions that correspond to the teaching and learning of any kind of praxeology, so that are common to all, or to at least several, bodies of knowledge or disciplines or types of knowledge. An example could be the notion of competence that is now introduced in school systems is a notion that corresponds to this pedagogical level because it is supposed to be applied to any kind of subject matter. Then we have the level of the schools, where there are all the infrastructures provided by educational institutions of any kind. In our small didactic system, the school is this conference. A conference can be a school. School is not necessarily the school in the normal sense. A university is also school. A family sometimes can be also school. And then these schools belong to societies, and these societies provides means, sometimes explicit, other times more implicit, about how to disseminate knowledge, what can be disseminated and what cannot be disseminated, which kind of praxeologies or types of knowledge are we including in curricula, etc. And then when these conditions are shared by different societies, we call that civilizations. Sometimes it's important not to think in civilization and contemporary civilizations, but in past, in historical civilization. What was considered as important to be taught in the old times, in the medieval period, etc. And then all that is common to all these levels is what corresponds to the level of the humanity. So why do we have this scale? To point out that when we look at the didactic system, we have to take into account that conditions, that what happens to this didactic system can come from different places, from very general places. And that as didacticians, as researchers, we have to take into account this amount of possibilities. This is why I was talking about unit of analysis, because as we see, the unit of analysis can be very broad, and the methodological problems associated can be very complex. Then we have the lower levels. I have put them here as a line. The lower levels correspond to what is specific to the content. We have when we have a didactic system, let me try that, yeah. When we have a didactic system with a piece of knowledge, a body of knowledge, or a praxeology, when we think about solving a problem like the one Luis presented with counting the dots or the configurations, the patterns, we have a piece of knowledge, and this piece of knowledge usually corresponds to a knowledge organization, and we can distinguish different levels. The topic or the type of task that we are solving, then the theme, something broader, the domain, the sectors, and the disciplines. Usually, we have knowledge organizations. That praxeologies are not just one besides the others, but they are a structure. And we can use the notion of praxeology to describe these topics. For instance, a topic is a praxeology built around a type of tasks. When we have several types of tasks that share a common technology, then we have a theme. And when we have several technologies around the same theory, we can talk about a domain. I will not enter into this detail here, but the notion of praxeology helps us describe all these dimensions that is also very important in the didactic analysis. For instance, let's take an example about negative numbers or integers. It's not the same if we consider knowledge organization as it is today around numbers and measure, arithmetics. Today, negative numbers are taught within the domain of numbers and measure, or any other type of label that you can put. It was very different many time ago when they were taught in the domain of algebra. They were even called algebraic numbers. So the condition to teach and to learn integers, the product, for instance, the product of two negative numbers, it's completely different if we consider that this level is built around the arithmetical, the numbers, or it is the algebraic domain. So in the didactic analysis of a single didactic system, this level is important to be taken into consideration, as well as the others. The analysis of the evolution, how these levels within the discipline are made, how they are selected and organized, is what corresponds to the theory of didactic transposition. Okay, what happens if we don't take into account this level, this intermediate level? What happens if we only focus on the didactic system to see how the teacher can do it better for the student to learn it better? Then there are some assumptions that we cannot see. For instance, in this way of structuring mathematical knowledge or school mathematical knowledge, there is a preponderance given to the synthesis, to the logos blocks of the praxeologies. And it's through the synthesis, through the logos, that the praxeologies are structured, not in terms of the problems and the type of problems. There is also an unawareness of the origin of this organization. So we think that there is only one way. Negative numbers today, they belong to the kingdom of numbers and measure. And 100 years ago, they belonged to algebra. But we think it's the only possible way. We think that this is the unique way of considering the mathematical organization. And then there is this tendency to take the school knowledge organization for granted, as if they were unique. Okay, so this is the first part of the lecture, to think that we talk about knowledge in terms of praxeologies. We want to know how didactic systems, they emerge and they evolve. And then we want to, when we look at the ecology, the conditions where these systems, didactic systems evolve, we consider the levels of codeterminacy. Let's now look at an important part of this, at the constraints that we can approach through the levels of codeterminacy, and that we formulate in terms of paradigms, pedagogical paradigms. When we consider this scale, And also when we have introduced the notion of didactic system, we are assuming that teaching and learning processes, they are built around bodies of knowledge, around praxeologies. This is an assumption that is rather normal. We assume that the curriculum is made of a piece of bodies of knowledge, of praxeologies, and then the students, they have to visit or encounter, if you use the metaphor proposed by Luis, these praxeologies, these bodies of knowledge, under the guidance of the teacher. This is what we call the paradigm of visiting works. The contract, the educational contract, is built around a selected pieces of works, knowledge works, and the students have to encounter, visit, know them, acknowledge their existence, and also even their importance. This is not the case for all didactic systems. If we think, for instance, in a PhD process, a PhD process is a didactic system that takes sometimes 3 or 4 years. It's a long didactic system, but it's not built around a curriculum as pieces of praxeologies or bodies of knowledge. It's different. So this paradigm is a little restrictive. We are assuming that the world is in a given way and cannot be different. So we need an alternative. And we also need an alternative because there are some phenomena related to this pedagogical paradigm. An important phenomenon is that this paradigm creates a frontier between the level of the pedagogy and the level of the didactic system, of what is specific of the content to be taught. Let me try again the example of competencies. We propose a notion, the notion of competencies at the level of the pedagogy, as if it was directly applicable to the didactic system without any knowledge organization in between. So because we think this knowledge organization is unique and we don't question it, then it becomes transparent, and we think that things that can go directly from the pedagogical level to the didactic without taking them into account. A second phenomenon is what we call the monumentalization of curriculum. At a given moment, and this is very current in today's schools, students, they have many pieces of knowledge to learn, but they don't know, and we don't know how to tell them why they are for, where they come from, and why is it important to study them. In order to avoid this negative phenomenon around the paradigm of visiting works, Yves Chevallard proposes to consider another paradigm, an alternative paradigm from which to consider the current one, and it's what we call the paradigm of questioning the world. He presents it as a counter paradigm, but in fact it's not an antagonist, it's a broader paradigm that includes, as we will see, the paradigm of visiting works. He says that what the new didactic paradigms aims to create is a new cognitive ethos in which, when any question Q arises, X will consider it, and as often as possible will study it in order to arrive at a valuable answer A, in many cases with a little help from some Y. So what we have here is a change. The didactic system is not centered anymore in a praxeology, but in a question, in an open problem, in an open question. We will see how the study of praxeologies, the study of knowledge, is also part of this didactic system. In this new paradigm of questioning the world, we need a tool that is what we call the Herbartian schema. A Herbartian schema is just a way, a very synthetic way to define the process of learning a question. So we have, again, the didactic system. We have a group of students, a group of teachers, and now a question. At the end of the process, we have an answer that we call a heart. Heart because it's important, it's at the core of the didactic process, this answer, and also because it's the answer of the students and the teacher. We have a generating question. We have a group of students and a group of teachers that we call study supervisors. And then this final answer. And I thank Luis for helping a little bit with this idea of milieu. In this process, there is a milieu, and this notion is inspired from the theory of didactic situations. Let's see an expanded version of this schema where there are some elements in the milieu. What is in the milieu? In the milieu we have some bodies of knowledge, some answers, previously established answers, some labeled answers. For instance, you can say, oh, you need a little bit of algebra to do that. You need to diagonalize a matrix. So we have some answers that are already available in the world. Then there are other objects or work of knowledge that are directly available for the system. So we have old knowledge. We can do things because we have something we already know. Then there are auxiliary or derived questions. From the first question, there are some derivatives that appear, and then collections of data. We will see that the milieu evolved during the inquiry process, and that this dynamics is described in terms of dialectics. This is what I was in the title of the talk. It was the model for inquiry. This is the model we propose. And we will see how in this model, the study of these answers corresponds to the visiting works paradigm. Let's see the two dialectics. And then I will give you examples. Sorry if this introduction is general and abstract. The first important dialectic is the questions-answers dialectics. So in the inquiry process, we start with a question here, and we have some knowledge available, but what we start doing is proposing derived questions. These derived questions, we will then search for some answers to these derived questions. Some of them will be outside, we will have to gather them, but we will have to include it in the milieu in order to answer these derived questions. And in the study of these answers, new questions will be raised, and then we will have a kind of self-sustained process. To describe these question-answers dialectics, we use what we call question-answer maps. And these maps provide a description of a piece of activity, a mathematical activity, or even a domain, which is very different from the usual one in terms of notions, definitions, theorems, solutions, etc. The second dialectic is the media milieu. The media milieu dialectics corresponds to the gesture, very typical in research. When we have a question, the first thing we do is to look if there's some answer somewhere in the world, before or during the study of this question. This is what we call the search in the media. A media is any source of information like books, internet, experts, teachers, whatever can bring me some answers that are not the hard answer. They are just possible, available answers that I will have to deconstruct and reconstruct in order to elaborate my own answer. And again, this integration of the external answers into the milieu generate new questions, and again, the process will be self-sustained. In this incorporation of the answers A labeled into the milieu is where we can include the study of works. Well, why is this schema for? This schema is to help researchers ask questions about a given teaching and learning process. So if you consider a teaching and learning process like a lecture, this lecture or any lecture or a course, a whole course, we can ask, well, what is the question here? Where this question comes from? Who posed the question? And how is it posed? How the students are assuming it as their own question. We can also ask about what kind of final answer is required and who is accepting it and validating. We can also ask about the available media. What works are already available? What data can be accessed? What questions can be posed after this? Which answers can be available, and are they really able to be incorporated into the milieu? And then, very important, what are X and Y doing with all this? Who is proposing the derived question? Who is searching the answers? Who is integrating in the milieu, etc. Just an exercise. Imagine that you are considering a typical course-based, lecture-based course in course and tutorials. Well, sometimes the answers are not there. They arrive at the end. They are the applications. And the data, empirical data, is not always available. It is sometimes suggested only. And at the end, the answer is the answer that the teacher wants the students to learn. So in fact, the praxeology is replacing the question. In a very open problem-solving activity, we have another schema. We have a question here, but the students are not allowed to look for answers outside the didactic system. They have to work with just what they have, and then they have to produce an answer, which is a kind of restrictive process. And then we can imagine another, also very typical. We have a praxeology. We look for a question that we think will generate the praxeology. This can be a kind of formulation of the notion of fundamental situation. We are not allowed to look for answers outside, but we have to generate something that resembles to the praxeology. In some cases, this Herbartian schema shows what we can call fake inquiries. And this is how Chevalier depicts it. In too many cases, the so-called inquiry-based teaching resorts for some form or another of fake inquiries, most often because the generating question Q of such an inquiry is but a naive trick to get students to meet and study works O the teacher will have determined in advance. In contradiction, in the paradigm of questioning the world, the curriculum is defined in terms of questions. And then, what about the works, the praxeologies? They haven't disappeared. The work studies, when inquiring into these questions, play a central role in the process of defining and refining the curriculum. So let's move to the research we have done using this broad unit of analysis and the Herbartian schema in the paradigm of questioning the world. What we do when we implement a teaching and learning process using the Herbartian schema, this gives what we call study and research path. So a study and research path is just starting from a question, from what we call a generating question, that in our case have been chosen because we want to overcome some previously identified didactic phenomena, but it's a question that is real enough for the students, it's not just an invention. To study this question is a collective work. The students work together. It's not that each student have his own research process. They can do that in teams. They can share the different tasks in different teams. And then they are supposed to contribute with weekly intermediate reports to propose some intermediate progress. And then at the end, they have to produce an answer that has to be defended, for instance, in front of an evaluation panel. And it's important to agree on what this final answer should be. So to give a kind of external command on this answer. How do the dialectics can be implemented? So the questions answer dialectic when we design a study and research path, we don't want that the path is pre-established, but we do an in-depth analysis of the question to see that the generating question is able to generate several derived questions and possible answers. So we do a priori question-answer map to study the question generating power, and then we let the process as an open process with surprises. We have to analyze how the media milieu can evolve, this dialectic can be implemented, and it's very important that the teacher is not assuming responsibilities. On the contrary, in a normal lecture-based or traditional teaching process, the teacher is usually acting as the main media source of information and also the main milieu in the sense of validating. Here, we have to imagine other kind of devices to let students search for information outside the class and validate this information together with the guidance of the teacher, but not with the direct help of the teacher. So there is a change in what we call the didactic contract. There is a change in the sharing of responsibilities. Who is planning the process? Who is raising the questions, prioritizing, reporting and validating, agreeing on a final answer? It's not the teacher who leads the process. The teacher is just supervising and helping, but the students have to take responsibilities on all these gestures. I want you to present just 2 examples of this study and research path to help me formulate the problem that we have with this. One example is a study and research path that is implemented to question some parts of the curriculum that generate dysfunctions or negative phenomena. For instance, the praxeological analysis of the curriculum shows that there is a disconnection between proportionality and other functional relationships. So we have implemented a study and research path to try to overcome this phenomenon that comes from the monumentalism. So we try to do, in the paradigm of questioning the world, try if we can fight against some negative phenomena that appear in the paradigm of visiting works. And then I will also show another bigger one on the modeling at the university level. Let's focus on the first one. So as I said, we consider in this school organization of contents a phenomenon that appears in the level of the domains and the themes. Proportionality is, in a way, because of process of didactic transposition, located in a strange way in arithmetic, in measure, but not in functions, but that the linear functions appear, so there is a kind of problem there. And we implemented a study and research path just to show that proportionality, just for the students to be aware that proportionality is just one relationship among many others. For this, we propose the initial question is how to save money for the final school trip. And then the students had to propose different installments and different ways to organize the installments. And then there appeared different functional models to describe the installment and see if we could earn enough money at the end of the year. So there were different relationships that appear, and they had to be compared. This was implemented during 4 weeks with lower secondary students level, and what was questioned at the level of the curriculum was not only proportionality, but all that is around that intervenes in the study and research path. This was an example. I don't want you to understand that. It's just to see what is a kind of question-answer map that appears as an a priori tool to describe the generating power of the initial question. Then we have another type of questions around study and research path, which is how to use them to cover a whole university course. At the university, we don't have the same strong curriculum constraints, And so we tried to organize different workshops on modeling that were mainly based on the implementation of study and research path. This is one of the first that we implemented, and here what were questioned by this study and research path was the domain of disciplines and sectors. The idea was to start with a question about how to predict the evolution of a population. The aim was to present mathematics as a set of tools to model different scientific phenomena, starting from the logic of the phenomena and not from the logic of the synthesis. And then we organized a modeling workshop in parallel with the normal course based on lectures and tutorials. And it was implemented during 4 consecutive years with a group of 40 to 50 students. And this is what we can say the skeleton of the study and research path, which has 4 branches, one on mixed generations with sequences, on independent generations with first-order recurrent sequences, and then homogeneous population, the continuous case that was in a way parallel to the discrete case before. And finally, let me talk about another important study and research path that was initially organized to work with functions, to fight against the monumentalization of functions. But in fact, when we implemented it as an after-school activity, so we could weaken a lot the school and pedagogical conditions. What we see in this study and research path was important, the unexpected outcomes, because we realize how hard for researchers and designers and teachers it is to free ourselves from the visiting works paradigm. For instance, we started asking, well, we are designing this study and research path, how do we plan in the next weeks the work? And then we realized that the teacher is not the one who has to plan the work, but the planning is something that has to be done with the students. The students have to learn how to plan. Then the first day, we just proposed a question to the students that didn't have data and there was no internet in the class. So we couldn't start the study. And they decided to invent some situations. So they invent some elementary exercises to start warming up. So again, it was the student who invented the examples instead of the teacher. Then they started, they had to compare tariff rates from mobile companies. And they had a lot of possible situations, and they were starting to compare. And so after 1 hour and a half, the teacher say, well, okay, you have done enough work. And the students say, no, we haven't done enough work. We have to compare everything with everything, because we want the result. We want a final answer. So again, we discovered that it was the final answer who was leading the students against this idea of the teacher, that what was interesting for the students was to use functions and not to find the best telephone rate. And then, well, they elaborate some final reports. They also propose some paths that were not expected, like start analyzing the bills of the students to make a kind of statistical analysis to check of their proposal, and also to elaborate final reports in terms of a website, and depending on the kind of information they asked to the user, they proposed 3 versions: for normal people, for lazy people, or for very lazy people. At the very end, it was also surprised that they decided to write a letter to the minister to complain about the opacity of the information. Okay, this is one of the first study and research paths, but these learning outcomes were important to see about the institutional constraints. These institutional constraints can be gathered and associated to the different levels. And the most important thing is that we can see that the study and research process starts with a question that do not necessarily belong to a previously established knowledge organization. So the didactic system has to be put before the level of the discipline sector domains, because a question is not a disciplinary question. It can be. Even if it's a question of mathematics in the discipline, we don't know the sector, domain, etc., where this question will belong. So this scale of levels of codeterminacy was the scale from the paradigm of visiting words, and it has to be changed when we look at the paradigm of questioning the words, because it is part of the inquiry process to find and delimit the praxeological tools that could be useful to produce the final answer. But so these are the two scales. But let me hurry a little to finish with the institutional constraints that have been found during this year of experimentations. And here, it is important to take into account the higher levels of the scale as well as the lower. For instance, it's a very important constraint and very easy to identify is the fact that the curriculum is a sequence of praxeologies, and then this is difficult to make it compatible with the questioning the world paradigm. It's also important to be aware that the society is limiting the access to knowledge. There are some pieces of work that have to be learned before others. So integers have to be learned before algebra, and derivative have to be learned after limits. So the society and the way we organize knowledge puts a kind of sequences that is not the logic where the study and research path is carried out, because we don't know in advance what kind of knowledge we will need. And there is also a tendency in our societies to an inhibition of the questions. It's difficult for the students to raise questions and to keep questions alive during long periods of time. Well, it's easy to find a lot of constraints at school in terms of time schedules, classroom equipments, frontiers between disciplines, capstone exams, and then at the pedagogy too, because it's difficult for a teacher, instead of lecturing, to do supervising or leading of the inquiries. I'm finishing. Just let me point out an important constraint. We find that there are a lack of routines to help teachers, to help students raise questions, address them, search for answers, test the information, share the results, organize, plan the inquiry. These are constraints that have been found in this research, but also in many other investigations about inquiry-based learning. The question is, to what extent these constraints are at the level, or can be addressed at the level of the pedagogy, or are in fact didactic and epistemological tools that are needed. So what I want to point out, and this is the open problem, is precisely how these kind of questions, difficulties, have to be addressed at the level of the pedagogy or at the level of the disciplines. Let me explain it a little bit more, and I'm finishing. In a study and research path, the students and the teachers inquire about questions that are not necessarily important in the mathematics domain. So there is no specific terminology to name them. The available synthesis, the works that are there in the books, on the web, they present the results of previous inquiries as synthesis, without including the intermediate questions, the dead ends, the provisional rejected answers. We are following this very economical way of transmission, which is what Thurston's talk about, the definition theorem proof model. In a study and research path, this is not enough. So X and Y have to elaborate their own narrative of the inquiry process and establish their own milestones to mark the path and set the pace. So they need words, they need terms, they need tools knowledge tools, but also only linguistic tools, to speak about what has been done, what is to be done, what has been established, what is provisional, what is to do, how to share actions that we cannot even name. So there are a lot of missing tools that are of mathematical nature, but not of mathematical in the way of visiting words. They are not synthesis in the sense of Bulligan, but there are other kind of epistemological tools. So let me finish. Well, in recent experimented studies, some of these elements of the Barthian schema have been used, but I will skip that just to finish with the question. The lack of epistemological resources to manage inquiry process seems to be one of the main open problems raised by research on studying research path. Conditions of visibility and legitimacy should also be taken into account, which inevitably involve the mathematicians community together with other scientific or scholar communities. And thank you very much.
Thank you, Marianna, for taking us on a very interesting and insightful theoretical framework of how we might envisage the teaching and learning of mathematics. I think we might have time for perhaps just one question, and then I'll ask people to talk with you in person afterwards. Is there someone who would love to ask that question? No? Well, I would like to say thank you again. That's absolutely wonderful talk that you've given us. Thank you.